All right, so now that we've taken a look at the inverse sine function, let's look at the inverse cosine function. Can the cosine function have an inverse function? Well, like we saw with the sine function, the answer is yes, but only if the function is 1-to-1. So let's look at an example. Example 1 says, if cosine of pi is equal to -1, then the cosine of -1 would be equal to pi. Here's the formal definition. The inverse cosine function, y equals cosine inverse of x, means that x is equal to cosine of y. The inverse cosine function is sometimes called the arc cosine function, and it's notated as arc cosine x. In this class, we will say that y equals cosine inverse of x has a domain from -1 to 1 and a range of 0 to pi. Now, let me just pause for a minute and make sure that you see the difference between the cosine and the sine. For the sine function, recall that it almost looked the same, still had the same domain, but remember, in order for this to be 1-to-1, for the sine function, instead of going from 0 to pi, we went from -pi/2 to pi/2. And the reason why we did that is because it gave us a 1-to-1 function, and it gave us a sprinkling, you might say, of positive and negative outputs. For the cosine function, notice the same sort of thing happens. If we restrict our range of the inverse function from 0 to pi, we're going to see not only positive outputs, but negative outputs as well. So we get a little bit of both. In blue is that cosine function that's being restricted. And we have the graph of y equals x. And then in red, we see the inverse function. Now, one thing let me point out here is that one of the characteristics of a function and its inverse is that they reverse inputs and outputs. So on the graph of y equals the cosine of x, one thing that we know is that at pi/2, we have a cosine of 0. So what we know is that the cosine of pi/2 equals 0. So if we really have found a cosine inverse function, then what we should be able to say is that cosine inverse of 0 is equal to pi/2. And sure enough, if I move 0 units on the x-axis as my input, I see that I am up at pi/2 for my output on my inverse function. Example 3. Use a calculator to find the cosine of 0.5 rounded to 2 decimal places. So using your calculator, go ahead and input the cosine of 0.5 and see what you get. Remember that when we're dealing with a cosine, that the input is an angle. And because we don't see any degree markers on this one, we can assume that we are in radians. So I get an answer of 0.88. Make sure that you agree with that. Based off of this answer, cosine inverse of 0.88 should be 0.5. Now let's evaluate cosine inverse of -√3/2. So normally what we saw on part A was we're inputting an angle. Now we are looking for the angle that produces a cosine of -√3/2. Well, remember that that cosine comes from the x value of the ordered pair on the unit circle. I see -√3/2 at 5 pi/6, and I also see it at 7 pi/6. Now before I can put down an answer, I need to remember the restriction that I gave on the last slide. I said that my angle has to be between 0 and pi. And that is starting on the positive x-axis and moving counterclockwise. The only angle that produces an answer that fits that restriction is going to be 5 pi over 6. Of course, we could also say 150 degrees. One more example, evaluate cosine inverse equals 1.25. So just like we saw on part C, I am looking for the angle that produces an output of 1.25. Go ahead and see if you can figure that one out, either using your calculator or think about it for a minute. And I hope you came up with, wait a second, I can't do that. And the reason is because this whole thing is based off of a unit circle. What we know as we move around with the cosine is the possible x value. The largest x value that I can see is going to be 1. There's no angle that's going to produce as its cosine 1.25. So we say that this one is undefined.